So for step 3, it asks me to open a new drawing. In the beginning, I showed you that you can do it from here, but you can also do it by going to the top left of your screen, where you can see the BricsCAD logo. If I click it, I will get a sub menu where I can see more options. I will select the new wizard option. And here I get some more options on how to create my new drawing. I will be choosing the start from template. If I select the next option, it will suggest me the basic templates that come with the application. You can also browse other templates that you might have created for yourself. But for this exercise, we will use the mechanical-millimeter.dwt template. Once I click finish, I will be taken into the new drawing. Now, when you sketch in BricsCAD, you can, of course, just sketch freely in the model space as such. But in this exercise, it instructs us to set up a certain set of variables. So I am going to do that. As it says, it wants me to change the snap type. This I can do in the command line at the bottom of my screen. So I will activate snap type, and it tells me to set it to 0, which I will do. You can see now that the command is active. You can see it through the command line dialog, that it tells me what to do for the next steps in the active command. And I will feed it the information it asks for, and as it tells me in the instructions. So sometimes in the training further on, you will also be asked to access different options that will appear in the mechanical or in the command line dialog that you can do down here by either typing in the value, and in newer versions of BricsCAD, you can also just click the different options. So I will continue typing the values and the commands listed in the training, such as snap mode, which I will set to 1. Grid mode, I will set to 1, and orbit auto target, which I will set to 1. Orbit auto target is a useful command just to keep in general, as it will automatically target things that you will rotate your drawing around. Also, it is asking us to change the visual styles. So you can right click on the look from tool as well to change the visual style. However, in the guide, it tells us to use the specific command for this, which is also possible. It will then open up a window where I can see the different available visual styles, where I can also create a new one. But here I'm just going to activate the 2D wireframe as instructed. And from here, I can start modeling or creating the sketch in the next step. You can do it from this angle, but you can also go ahead and use the top option on the look from tool, and you will orientate yourself with a top view of your sketch. And now we can start sketching. So in step 6, it tells us to call the polyline command. We can do this by typing p-line in the command bar, or command line. You can also do this from the sketch tab and using the polyline option here. It might not be very easy for you to see it on the grid here, but my cursor is snapping onto the grid. You will notice this more clearly when you start doing the exercise yourself. And there I started sketching in the origin point of my drawing. And I will sketch as it is showing me in the handout. So this first line, I will make 200. I don't have to type in any values because I am using the grid to model. So I am just snapping onto the different options here. or the different grid positions. So I first made a 200 millimeter line, then 100. Then this one I can see has a 135 degrees angle with a length of 70.71 millimeters. So I will click to accept this. Following that up with a straight or vertical, not vertical, horizontal 100 millimeter line. And then another 130-degree downwards line of 70.71 millimeters. Now I can manually attach the last point here down here to finish my sketch, but I can go down to the bottom of my screen to the command line where I can see the different command line options. Here you can see the different options such as the close option, which is what I will use. To do this here in newer versions, I can just click this option, but you can also type C or type it all out close in the command line and accept it. And it will automatically close the geometry for you. And it is now listed as a, or classified as a polyline. Now that showed us how to model with a, or sketch with a grid. From now on, we will be working with a solid. So I'm going to follow step 7 and turn off some of these variables again, such as I can set snap mode back to 0. I can set grid mode back to 0. And I can change the visual style back to mechanical. This time I'm doing this from right-clicking on the Look From tool, hovering over the Visual Style sub-option, and selecting Mechanical. But of course, you can also do that by using the Visual Styles command as we did earlier. Now we will want to extrude this command, or this sketch, I mean. For this, you can either highlight or hover over the, or select the sketch itself, or you can use the boundary detection. The only difference is that if you use the sketch to extrude, the sketch will be consumed and it will only be left with a solid. If you use the boundary, you will still have the sketch here. However, for this exercise, it is not that important exactly. So you can type in the dm extrude command in the command line. Ooh, I'm going to change the color just to make it a bit more pleasant to look at. So I can type in dm extrude and then extrude it downwards to or 20 millimeters as instructed. Step 8 is also telling me to change the color of this base to green, so I will select it. To select it, you can hover over your model and hold down your Control key to have your solid highlighted. While it is highlighted like this, I will click it, and then I have my solid selected. I can also use selection windows. You might be familiar with this, that you can click somewhere on your screen and drag your cursor to either side. If I drag my cursor to the right side, it will select anything that is completely engulfed by this square or this selection window. If I drag it to the left, it will only, or it will select anything that just touches this selection window as such. And then from the properties panel, I can go to the color section or color option, and I can then select the green color. Again, if you do not have this property panel, you can right-click on your ribbon, hover over panels, and you can find And you can find the properties panel down here. So for the next steps, we are going to be using sketches, and we will be sketching on the solid model itself. Therefore, it is useful for you to have the dynamic UCS activated. You can see if you have the dynamic UCS activated down on your status bar, it will be called DUCS. And here you can toggle it on and off, similar to the eSnap settings. You can also use the F6 key on your command or on your keyboard to toggle this setting. What this DUCS option or dynamic UCS will do is that it will align the origin point in a sense to what you are selecting or hovering over when having a command active. I will be showing it now. So for step 10, I will be activating the rectangle command. You can do this through the command rectangle, or you can go to the sketch tab where you can see this menu here. It is called polygon, but under it you can find the rectangle option. And now I can choose what sides of this to sketch on. As you can see, the coordinate system is kind of adapting to the face I am putting my cursor on. And this is what the dynamic UCS does. So now it is aligned with this surface, and I can sketch on this. However, if I want to be completely sure that it is locked onto this surface and my sketch will stay on this surface, I can then click the Shift key on my keyboard while hovering over it, and it will turn a darker color. And then you will know that what you sketch will remain in this plane. So I will just change the color of my sketch so it is a bit easier to see. And then I will start drawing my rectangle. I just click somewhere to start the command or start the rectangle, and then I can select the second position to finish it. I will also be prompted with these measurements, as you can see. The one that is highlighted in blue is one I can currently edit by typing on my keyboard. And I will then give it the value of 60 millimeters in that direction. To change to the other measurement, I can press Tab on my keyboard, and it will change to the other one, and I can type in 20 millimeters there as instructed in the guide. Now it is also saying that this rectangle should be aligned in the middle of this edge here and along or up against it. To do this, we can use the move commands. So I can select my rectangle. I can use the move command or DM move command. Now I want to snap the midpoint of my rectangle onto the midpoint of this back edge. This is where the eSnap settings are important. So you need to have the midpoint snapping options active. If you do not have it active in the eSnap settings on your status bar, you can always hold Shift and right click, and here you can activate it. And then I can select the midpoint of my sketch. Now I can move it around freely, as you can see. And then I can snap it onto the midpoint of the back edge. Once that is done, I can extrude it similarly to what I did with the base flange. I can now show it by selecting or just hovering over the sketch, and I can go into my quad under the model tab. And here I can find the solid extrude option. And I will give it a value of 150 millimeters as instructed. in the guide. Following this is step 11, where I will create a circle on this face. To do this, you can type the circle command in the command line. You can also go to the ribbon and activate the circle command. Again, you need the midpoint snapping options, as you want to start the circle off in this midpoint. Make sure you are not aligned with this top face, as the sketch or the circle will be tilted the wrong way. You will have to sketch it on this face. And again, to make sure that you do so, you can hover over it and click Shift to lock into the surface. So now, even if I hover over the other face, it will still sketch in the face that I locked into. So I will draw the circle sketch. It does not give me a value in the radius. It only tells me to snap onto the corner of my model. So I will need the endpoint snapping option active, as this is listed as an endpoint. Again, you can find the snapping options in eSnap on the bottom of your screen in the status bar, or by holding Shift and right-clicking. And so that distance decides my radius. From then, I will similarly, again, extrude my circle. I will extrude it outwards like this by 130 millimeters. Now for step 12, you can see that there is a bit of a notch in the back here. As this is where the sketch originated from, and I only extruded it in the direction outwards from here. But I would like to make this backside flush. And to do this, you will need to pay attention to your selection modes. You need to have the selection of faces active, because then you can hover over and select this back face or the half circle back face of this cylinder geometry. And then similarly, you can extrude this as well. And you can snap it onto the endpoint here, for example, or the midpoint. And it will extrude the geometry until the endpoint there. And so I have created a flush, nice look on the back of my model. Now to introduce something new, there is something called design intent in BricsCAD. If I go to the solid tab, as we are doing solid editing now, you will see the section called design intent right over my cursor here. These settings will determine how your different solids or the geometry of your model behaves depending on other aspects of your geometry. So if I now try to move this face here, I will just hover over this face and I will call the push-pull command through the quad and the model tab. You will see that I can push and pull on this face and extend it and shorten it. But with this design intent option here that I will activate called coincident planes, it will detect places that are coincident to each other. And if I've done everything correctly now, this face should be coincident with the bottom face of the base. So if I now again try to push-pull on this face, it will also adjust any coincident faces on my model. So that's an example of something the design intent can do. We will also see more of the design intent options later in the training. But first, I would like to hollow out this cylinder right here. To do this, I can create another sketch, or another circle sketch as before, but I can also hover over it and go through my quad to the draw section. Here I can find the offset tool. I can also select my face and then go to the Sketch tab where I can also find the offset tool. But I find it easier to just go through the quad and getting used to using it. Here you can see it is creating a offset sketch of the outer geometry of the cylinder. So it is taking the shape of the cylinder and it is offsetting a new sketch for me. I will move it inwards and give it a value of 10 millimeters. So now I have created a sketch that is circular, offset 10 millimeters from the outside of the cylinder. Then, like before, I will select the sketch and extrude it. But instead of adding material this time, I'm going to go in towards my model and all the way through so that I extrude a hole all the way through my model. If your program does not remove material, you can check the bottom here, right over my command line. You can see there are different control toggle options. If you have your command active and you toggle the control button on your keyboard, you can toggle between options such as now it is in the auto setting. If I toggle, I can go to the create option where it will only create new material. There is also subtract and unite. But I will just let it go on auto and it will detect for me that I am removing material. The distance doesn't matter as long as it protrudes away or through the back face here. For step 16, we will try a new design intent in the solid tab. Here I will activate the coaxial surfaces option. This will detect any surfaces, circular surfaces that share a center. That will share a center and revolve around the same point, which should be these two faces or these two cylinders. So if I try to now use the DM move command, I can select that I want to move the outer face of this cylinder. And I will select this, and now I can move the cylinder around, and the inner face will stay coaxial and share the same center as the outer face. If you try this and you try to move it around, you might see this result where you move your cursor and nothing is happening and it turns red. If you hold the shift key on your keyboard while you're trying to move it, the cursor or the movement will lock itself to a certain axis in your drawing. So if I now hold shift and I move my cursor up along the Z axis, it will stick to this axis even if I move my cursor around other places. So that's a little trick to make this, or trick to make it a little bit easier. If I disable this coaxial design intent and I try to move it again, I can show you what happens. I will select exactly the same things as before, and I will try to move it, but now it only moves the geometry of the cylinder and the outer face, and the hole that goes through it will remain in the same place. So that will show you how the coaxial design intent works. Now to add some more detailing to our part, we want to add some fillets to the front of the base here. We can select the edges one by one and apply a fillet, because that is what is instructed to give it a fillet. But you can also select both of the edges at once. Make sure you have the selection of edges activated on the top of your screen. And then we can type in the command dm fillet, or we can also go through the quad to access the fillet command, or you can also go through the ribbon, of course. And I will give that a value of 25 millimeters as such. Following this, we want to create 2 holes as well on the base. And we want these holes to share the same center as these radiuses or radii. So for the next exercise, you will need to have the eSnap option center active, as you will see shortly. So I will just activate the circle command from the ribbon like I've done before. I will hover over the face I want to place the holes and click Shift to lock into it. Now with the center option or center snapping option active, I can hover over the curve of this fillet, and you can see that a plus sign appeared in the center of the fillet, which is a snapping point that I can place my sketch on. So by selecting the snapping point, I can then create my circular sketch. I will give this circle a value of 10 millimeters in the radius. And I will do that for the other side as well. Just hovering over the curvature on the top face, and then the center snapping point will appear. Now I want to create holes from these sketches, so I can again select the boundaries or the sketches like before. I can do it one by one, or I can select both of them at once, and then use the extrude command like before, and just pulling the extrusion downwards through the base until it is creating a hole, and just clicking to accept the extrusion length. Now, similarly to the fillets, I want to create some chamfers around these holes. You can do them also by selecting them one by one, or you can click and select both at once. And then you can go through the quad, the model tab, and select chamfer, or you can go through the command line or the ribbon. Once active, you can see a preview like with the other commands, and I can give it a value of, what is it, 5 millimeters, I think, yes. As such. Next up, we want to draw another rectangle on top here. We want to add some support to the underside of this cylinder geometry. So similarly to the earlier step, I will activate the rectangle command, lock onto the surface on top, and create my sketch. This sketch should have its longest side pointing away from the existing support. So I will give the short side here a value of 20 millimeters, the long one a value of 50. Again, I type in the value and I press tab to tab between the different measurements. Hit enter to accept. And similarly to before, I can move this part by snapping onto the middle here. And I can move it by snapping onto the midpoint of this line or this edge of the support here. Now I want to extrude this as well, so I will select the sketch, use the extrude command. But instead of giving it a value, this time I want it to reach the outer geometry of my part. I can try to place it manually, but there's a risk of it poking through the other side here. So in the command line dialog, you can see there are some different options I have been given. I will be using the set limit option. I can click it here, or I can type L and enter into the command line. And then it will ask me to select a face or body to limit extrude. I want the outer face of the cylinder to be my limit. So I will select that face. And you can see it has been extruded to the outer limit of the cylinder. And it has adapted to the curvature of it without poking through on the other side. Even like in step 22, if you select both sides of the rib, you can do that and use the push-pull tool. That is the DM push-pull tool. Oh, there's a lot of flickering. But you can see here that I can change the width of the geometry, and it will still adapt to the size or the curvature of the cylinder. So even if you want to change the width later, it will still adapt with that set limit option. Next up, I want to add some simple constraints to my model. I'm going to go to the Solid tab under the Parameterize option. I can also type in DMFix 3D, but I'm going to select the key lock option here and apply a fixed constraint on the back face here. And I will use the radius option, DM radius 3D, to place on this hole. I will accept the existing value. And what this radius constraint does is that it can control the size of the hole to show what, or you can see in the mechanical browser on the left side of my screen, I have the different constraints that I have created. And I will be able to then change the value of it manually, but I can also right-click it and animate it to see exactly what it does. So when I animate it, you should see the hole change size so that I can see what exactly this constraint does. As you can see, only one of the holes moved, but what if I want the other one to change as well? Then I can either place a new constraint on this, although it's not necessary to place two constraints. I can activate the sign intent called equal radius, since the holes are of a similar size. And now it should recognize that these are the same size, and the program will try to keep them to the same size. So if I now animate this constraint again, you can see both of the holes change in size. Now, closing in on the end of this exercise, I want to add an angle constraint on this face. I want it to be angled in the vertical way. I want it to point a little bit more inwards towards the top. So I can use the command or the constraint angle, DM angle 3D. I will select the back face first, and then I will select the front face. For this specific example, it doesn't matter, but normally the side you select first is the one side that will change, and then the second side you pick will not move, I believe. And then, however, in this example, it's not important as we have a fixed constraint on the back here, so this will not change no matter what. So you can pick the back face or the front face first. The only issue now is that you can see the angle. Hopefully you can see that the angle is working horizontally rather than vertically. So if I were to accept this, the angle would not change or move in the direction I wanted to. Therefore, I have the option in the command line dialog to set a reference entity. The way this works is that now it rotates around a center point that moves in the Z direction, so upwards and downwards. However, I want the angle constraint to rotate around a line that moves along the x-axis. So I will select reference entity, and I will select a line on my model that moves along the x-axis. This small edge back here will move along the x-axis, and then should give me a line that will orient the angle to be rotating the correct way. And it might be a bit difficult to see, but the angle is now oriented the correct way. And I will just hit enter to accept this value. And in the mechanical browser on the left side of my screen, you can see it created an angle constraint with 180 degrees in value. If I select this constraint and go to the bottom of the mechanical browser, you can see that I can change the expression of it. So this is for now step 25, where I will change it by 10 degrees. If I change it by 10 degrees down to 170 degrees, you can see it's tilting forward. However, I want it to tilt backwards, so I will change it to 190. And that looks like the result I wanted. So now we have placed some simple constraints on the model. Lastly, I want to just add some cosmetic fillets onto this shape. You can do that by selecting the edges manually one by one. You can also hover over the face of this, for example, and you can go through the quad to the select category. And here you have an option to select all edges connected to this face. You can also hover over the edges, and you can have other options such as selecting an edge network. But for now, I'm going to use the selecting this option to select all edges connected to the face, and I can select some manually as well. So like before, you can chain or select several edges at once that you can apply the fillets to. Or you can do them one by one and so on. Just keep in mind that when you select several edges at once, you will have to give them the same value, as all of them change similarly, as you can see. So now I've given all of those edges a 3 mm radius.